Hello, everyone. Welcome to today's Antrea live show. Let's
Hey
see.
everyone.
Hi, hi, Scott. Today, we have Scott here to join us to tell us more about the Routable and Antrea with NSX-T. So, Scott, would you like to give us a short self-introduction about yourself?
Yeah, so hey everyone, I'm Scott Rosenberg. I'm the practice leader for cloud and automation at TerraSky, a VMware partner, a global VMware partner, as well as many other companies that we have partnerships with. And I lead the Tanzu portfolio internally and love Antrea and love Tanzu.
Yeah, thanks, Scott. Really nice to have you here. And would you like to share your screen and go ahead talk about those raw pod feature with us?
Yeah, for sure. So I think one of the really cool things is, this new integrations that we're starting to see more and more with NSX and Antrea. And so tell me if you can see my screen. There we
Yeah, we
go.
can see your screen
Awesome.
now.
Perfect. Okay, so one of the really cool things that we have is typically when we deal with Kubernetes. If I were to go here and do like kubectx2 PC demo CLS02, and did here just a kubectl get pods dash a, let's say dash oy. One of the things that we can see is that our pods are actually running with IPs in this like internal range that's being basically SNATed when we go out. And this is an overlay network using VXLAN technologies based off of OVS within Antrea. And this is great, and this works for us. And this is typically what we would want to use because we don't necessarily need our pods to be routable within the environment. They can go out through the node's IP address. That's the standard traffic flow that we get. And internally, everything is routed. But yeah.
So the IP here is the cluster IP that is that we can access from within the cluster, but we can't access that outside the cluster, right?
Exactly. Other pods can communicate with this within the same cluster, but anything outside of the cluster can't communicate with this IP address. It needs to go through an ingress or a service type load balancer or node port or some other way to access it. This is not directly accessible from outside. And the other thing that becomes difficult is that when this pod tries to access, let's say, a database sitting outside of Kubernetes, in the typical configuration, that's going to go out with the node's IP address. It gets SNATed out, so it's source NATed out to the network. And when I look at the access logs, for example, of the application I'm connecting to, I'm actually connecting with the IP address of the node. So there's no way of differentiating which node this is coming from. And when we're in a purely cloud native world, that's perfectly fine. But in a lot of enterprise organizations and a lot of large organizations, and they still have these large enterprise firewalls, that doesn't necessarily fly. Not everyone is the biggest fans of network policies. They want to manage things in a traditional way through a traditional firewall. And this can be a bit difficult, as well as there are certain types of applications that don't traverse NAT very well. So NATing doesn't work well in those specific applications. And there's actually a great solution for this, which is Antrea together with NSX-T. And Jay, so am I. I am also a huge fan of network policies, especially Antrea network policies. But, there are people that aren't. What can you do? We can't fix the world in one day. So we need to have a solution. And the solution for this is really a great integration that we have in Tanzu. It's built in, but we can also do this completely in the open source. Today, I'm doing it on Tanzu Community Edition. So completely open source distribution. And so what we can actually do is make these pods routable. We can actually get routable IPs for all of our pods. And just to show what that looks like, if I went here and did a kubectx to routable CLS01 and did now a kubectl get pods -o wide -a, let's say, and let's take a random pod here.
Sorry to interrupt, Scott, but just to make sure everyone can see what we're saying. So
yeah, everyone can hear. Jinjum seems to be having an issue hearing.
Okay, so maybe Jianjun can rejoin this YouTube link to see if it works for him, and I think we are good to continue.
Awesome. Yeah, so if we look here, for example, I've got a random pod here that's running the Aqua Starboard operator. And if I just came and pinged this IP, it's actually accessible from my own computer. And this is a really powerful thing that I could actually access that pod directly. And what I could even do beyond that is if I ran and just decided to run here some, let's say, jump box using a Ubuntu SSH container, which will take a second to come up here. See, this will take 1 second to come up.
So the IP we assign to each pod now is accessible both from within the cluster and outside the cluster.
Exactly. So this is completely accessible from anywhere. So if I did now a kubectl exec into this pod, right? So into the jumpbox pod. And for example, did an SSH to demo VC01 Terra Sky demo. Why not? Why don't I SSH into my vCenter? Yay. From within the pod itself. And looked here at, let's say, do a cat to /var log. It's under audit, I think, and then SSH info. We can see here accepted password for root from 10.101.2.9, the IP address that that pod received. If I go back out, we can see that that's the address here, kubectl get pods -o wide, and we can see 10.101.2.9. So any application that's coming from outside of my environment, I now also see which pod this is coming from. I actually get the IP address because I'm going out with that IP. And this is something that enterprise organizations, large companies really need in a lot of cases. And this is a really strong capability. Now, the other thing that this allows is it also comes into the cluster and also out from the cluster with this IP address. And the way this is set up is actually really easy. And what we'll do is I'll actually create one of these environments live to show you. So if I open up my NSX environment here, and let's say I'm going to go here, and basically what we need to do is we have this idea in NSX of a multi-tiered routing. So we have this idea of a tier 0 and then a tier 1 router. And then under that, we have segments, which are like port groups in vSphere. So what I'm going to do is just create a new tier 1 router. In this case, let's call it live demo routable pods tier 1. Why not? And I'll select here where I'm connecting to. The tier 0 is where I've configured BGP up to my physical routers in the environment. I don't need to select that. That's fine. And for route advertisement, we need to select all static routes, all connected segments as well. I also just always like to select everything because why not? And we can save that. And that's what we need to do here from a tier 1 perspective. So once we've configured this for our cluster, we would then go and actually create.
By the way,
Yeah.
would you like to show us the graph of the structure of the gateways, because it's really give it.
Yeah. Once this is created, I'll show it what this all looks like.
Okay.
So next, what we'll do is actually create our network itself, right? This is going to be our node network that our nodes are going to be sitting on. So in this case, I'm going to call it TKG Routable Cluster 02. And I'm going to connect this here to my live demo tier 1 router. Select the overlay transport zone here. And I'm going to give this a new address range. Let's use 10.103. No, let's do 10.100.181.1/24. So this is our nodes. This is not our pods yet. This is just the nodes themselves that are going to be sitting on this network. And I'm going to set up a DHCP server here because TKG Cluster API require a DHCP for our nodes to get IP addresses. So what I'm going to do here is set this to 10.100.181.2. And we're going to create a DHCP profile. Let's call this live demo TKG. And we're just going to give this the CIDR block of 10.100.181.1/24, which is great. And once we have that set up, we just have to select which cluster, save that. And so here we have our DHCP address, and I just need to give it a range of what I want those IP addresses to be. So we'll do 10.100.181.100 till 10.100.181.250. And that's basically all that I need to set here. I'll set also my DNS server and save that. So once I've created this, I've set up my network from all of the configurations that I actually need. We're going to save that, and I'm going to make one more change here just because of how my environment is set up. And I'm going to change a few of these settings. These are not needed. I just do them in my environment here because it's a lab environment. And now that I have my network set up, I can actually go and create my cluster. So if we take a look at what that looks like, is I have here a TCE demo routable CLS02 redacted file. Redacted because I don't want to show you my passwords. And basically, this is a standard Tanzu cluster configuration file. And one of the really cool things that happen here is, so we're setting, again, the cluster name, our control plane endpoint, everything that we would in a standard Tanzu cluster. And the magic comes here on lines 26 until 33. So I'm telling it to use Antrea as the CNI because, Jay put an old version of Calico in here, so we prefer to use Antrea. And we're going to enable trace flow, and we're going to set NSX-T pod routing to true. So I'm going to say, yes, I want my pods to be routable, and this is going to use an NSX integration that we have. I'm going to give it the host, my NSX-T manager. I'm going to tell it which tier 1 router it's supposed to use. I'm going to give it the password and user. This could also be certificate-based authentication, whatever you would like. And I'm in a lab, so it's self-signed certificates. Beyond that, that's all we need to do here. So once we actually went and configured this out, so we have our cluster, all we need to do is a Tanzu cluster create -f and give it the actual file. So here it's going to be the non-redacted file. So TCE demo routable CLS02.yaml, and this will create now in the back end. So this is just validating the configuration and is going to start creating our cluster for us. Now, while this runs in the back end.
By the way, would you like to explain more about the two parameters we were talking about, like the about 20, line 27 and 28. I think these two parameters are the one that enable this routable pod feature, right? Would you like to
So
explain
really
more about
just line 28. right?
just
Really
line
just line 28, right? This NSX-T pod routing enabled, and then we need to give it some parameters, which are the lines right under it. But if we
Okay.
actually look here at what this is actually doing, and this is, as people know, I'm a big Carvel fan, so I can go into some YTT here. So if we go into config, Tanzu, TKG, providers, YTT, 02 add-ons, CNI, Antrea, and I go into the Antrea file. So this is when Tanzu creates a cluster, it's using these files that are basically extracted from the CLI, and these are the files that configure our environment. And if I were to look here at this Antrea add-on data lib YAML file, one of the things that we can see that happens here is that within my configuration for Antrea, we see that if data values NSX-T pod routing enabled. So if we set that to true in our file, then what we're actually setting is traffic encapsulation mode to no encapsulation. By default, we're going to get encapsulation for our pods. So they're going to be VXLAN, and they will not be just, routable pods by default. They will be actually encapsulated. And we're setting no SNAT to true. So we're saying don't set any SNAT rules when a pod is doing egress traffic out to the world. And those two rules are basically what we need to configure from an Antrea perspective in order to get what we need. Now, the other thing that's needed is Antrea proxy is configured to true. So basically, setting Antrea proxy to true, that's, again, part of this integration is that we need Antrea proxy as well to handle our traffic for us. So we have this true.
So user only need to set the NSX-T pod routing enable. So that is the one that user will configure. And then the Tanzu CLI will translate this parameter into the traffic in cap mode and no SNAT, right?
And will enable Antrea proxy. Exactly.
Okay. Okay, that's really easy for user to configure because they don't really need to look into the Antrea's parameters to see which one they need to set up. They just need one.
Exactly. One parameter, and it actually does more than these, right? So this is part one. This is the configuration of Antrea. But then there's also the configuration of NSX-T, which is not done through Antrea. It's actually done through another component in our cluster called the vSphere CPI, or the Cloud Provider Interface, what interacts with vSphere for us from within the cluster. And if we look at what that actually looks like.
So the CPI configure the vSphere, right?
Yeah, CPI configures vSphere and also configures NSX. So if we look at what this looks like, and I did a bat here, and let's see if I remember which file this is in, because I do not know. I think it's in the add-on data lib. Yeah, I think so. Let's see here. Am I right? Yes. So one of the things that is configured here as well within our cloud provider interface, right? In any cloud today, we have a cloud provider interface. These used to be the in-tree cloud providers, what they were called, and now those are being removed from Kubernetes over the next few releases, and we're moving to the out-of-tree CPI cloud provider interface and CSI cloud container storage interfaces. And so here, what we're doing is actually all of those values that we had set, pod routing enabled, true, gets configured here. And then all of the values that we gave of what was my router path, which tier 1 router in NSX-T, username, password, host, the cluster CIDR, so that routable CIDR that I'm going to be running with. All of these things are configured for me automatically, right? So it's really easy the way that Tanzu brings this out, because I don't need to know exactly how to configure the CPI. I can set logical steps that someone needs to fill out, and all of this gets done for me automatically in multiple different places across the stack, right? So this is all configured.
Okay.
And then
so that user only need to one parameters, and there are the Antrea and NSX-T and vSphere are automatically configured for that.
Exactly.
CPI and Tanzu CLI take care of the rest part.
Exactly, right? So if we came, and that's really what this is doing, right? Those few values are changing these values, which are then affecting what gets deployed in my cluster. And that's a really strong, great user experience because we actually hide the complexity away with just some simple values. Now, what this actually looks like from a UI perspective, if we go back to what things look like in the UI, is actually how our topology in NSX-T works. So if I took a look here at, for example, the cluster that I already have, this TKG Routable Pods Tier 1 that I had created in advance. Well, the way that routing works within NSX-T is that we have this idea of a segment, which is a port group in vSphere. And connected to that, we have all of these VMs, right? So any VM that's connected is represented here, and they're connected to this segment. That's a subnet in our case. Okay. And this segment is connected to what's called a Tier 1 gateway, or a Tier 1 router, or whatever other name VMware decide to give it in the next version. I don't know. It was routers, now it's gateways. But this Tier 1 gateway basically is the connection between one or more segments to what we call the Tier 0 gateway. And the Tier 0 gateway is where we basically configure our connection out to the external world. So this is where on my Tier 0 gateway itself, if I were to go here, what we can actually see is that this Tier 0 gateway, I have BGP enabled here. And I'm actually configuring BGP against some of my physical routers in my lab here, right? So that's what we're actually doing here, and that's what's really strong. We have this multi-tiered approach of routing within NSX-T that allows us to get to really complex and really strong network isolation and segmentation capabilities, right? So now this has already been created. Our cluster is almost done being deployed. It actually just finished. So our cluster is ready. So let's go and do a Tanzu cluster kubeconfig get -- admin and just give it the cluster name here.
So this is the new workload cluster we just created with the routable enabled, right?
This is the new one that we just created, yes. 1 second, Tanzu cluster list. What's the actual name here? Yeah, the name was different than the file, that's why that didn't work. And let's actually give it the cluster's name when I try to get its kubeconfig. Great, I have it. And now I could do a kubectx to routable CLS02, and I can do a kubectl get pod -a-oy. And we've got an IP here. This is that's an errored out pod, so I wouldn't take that one. Let's take the pinniped concierge in this case. And hoping that the demo gods are with me. There we go. We have access to this pod. Now, how does this actually work? And the answer is that it's actually a really strong integration that happens. One of the things that Antrea does in terms of how it overall just, allocates the IP addresses, this was mentioned, I think, a few weeks ago on the show, was that we have this idea of the node IPAM controller within Kubernetes that allocates, we give a cluster CIDR to the entire cluster. In my case, 10.103.00/16, so a class B network. And what ends up happening with the node IPAM controller is that when any node joins the cluster, by default, a /24, so a class C subnet from that larger cluster subnet is allocated per node for pods. And that way, IP allocations happen at the per node level. If that were to be exhausted, a new CIDR would be allocated as well to that node. And so what's happening here is that each of our nodes, if I went into kubectl get nodes, let's say I take this one, for example, and do a kubectl describe node, that one, and actually look here, we can see my pod CIDR here is 10.103.2.0. And the IP address of this node is 181.103. Well, let's actually look at that from NSX and see how that actually works now. So if I go here to my tier 1 router and I look at my static routes, I can see that I have 4 static routes created. If we look here, again, what we were
Okay, everyone, like, so where's the Scott? I think I'm the only one here, right? Can anyone like see me? Ah, I can see that Jinjin said, okay, this time it's not just me, okay. Okay, yeah, I can see that people can see me now, so I will ping Scott to see if he can come back and join. I think it's some network issue with Scott, so. Give me 1 second to ping him. So, Jinjin mentioned that while waiting, want to mention no in-cap mode works with any Kubernetes cloud providers that supports adding node pod siders to underlay routing table, not just NSX-T. For example, it works on AWS Azure and GCE. Thanks, Jinjin, for mentioning that. And Scott said that give him a few minutes to rejoin. So let's see if who is like watching our show today. Jinjin is here, Jay is here, and hello Antonian, and hello Matthew. Hope I pronunciation your name correct. Okay. Oh, Scott is here. Hi, Scott.
Hi, everyone. Sorry, the internet just crashed in my office, so I'm connected to my hotspot right now. The fun of networking when you're about networking. So exactly. So yeah, basically. Hey, Jay.
I just came to fix the logo, and that was it.
Okay. Oh yes. I forgot to change the logo. Okay.
Oh no. You know.
Scott would like to share a screen again and go ahead finish that demo.
Yeah, I'm trying to see if I can connect to my network again because I'm not sure that I can, in which case it'll be a bit difficult to share because it's all sitting locally within my lab. So 1 second. Let's see. Let's see if there's any way for me to connect because I think the internet just crashed in my office, meaning my entire lab crashed as well. Yeah, no, the lab is completely down right now. So unfortunately, I can't continue to show that.
Okay.
But basically, so what happened is that our tier 1 router, so our actual network, we got a static route for each of our nodes directly to that pod CIDR. And that's where the real strength here comes in, because we get this automated integration here really easily for us, and all from literally setting 4 values in a YAML file to create a cluster. And that's, a really strong capability. So yeah, that's, really, I think one of the cool parts here with Tanzu is just like how these things are going forwards and how this actually works together with Antrea and with NSX to really make things just awesome and powerful.
Yeah, I agree. It's amazing features that we have in Tanzu, and like customer can enjoy that by using Tanzu. So yeah, thanks Scott for this great demo, and I think that we can. Does anyone has any questions before we move to the second part of this show? Okay. So now I will go ahead and share something about the Kubebuilder that we use to create the controller. And so from the, let me share my screen here. Okay, so from episode 13, we introduced AV to our audience, and it's AV is a load balancer that in Tanzu we use that to provide a load balancer type of service for the customer in the Tanzu cluster. So if you want to learn more about how AV works and what that is, you can take a look at the episode 13 from our channel, and Bushan gives a great demo and introduction about that. So now, what I want to continue that topic to show people how we, because the core part of the one of the core part of the AV is the AKO. So we need to run AKO in our cluster in order to provide all the load balancer functionality. So the topic here is that how we deploy AKO in our workload cluster. And so if we want to talk about that, there's one thing that we must mention is that we have something called AKO operator installed in a management cluster. And that operator will manage the life cycle of AKO. For example, if a workload cluster is created, the AKO operator will create AKO in the cluster. So that means that we need to take a closer look at what AKO operator is. So before we're talking about the AKO operator, let's take a look at what a general operator looks like. So we initiate the operator with the Kubebuilder, and that is I think that it's a really easy to use framework to initiate your controller. So now I want to do hope I can do the live demo smoothly, because I tried this morning, and if something goes wrong, we can just take a look at what I did this morning. But now I want to give it a shot and create a new one here. So now we are gonna create a new controller from the scratch. And after we take a look at this sample controller, we will go ahead and look at what a real controller, which is AKO operator looks like. So let's start. Let's create an object here. So before we started, I have already installed the Kubebuilder. So if you haven't done that, this is the first step. And after that, we can create this object. So let me start a new terminal here. And is that large enough for everyone to see? Maybe. Then create. First thing I create a repo here. Maybe we can call it desktop controller demo. Then I set it into this. Oh, by the way, thanks Ricardo for inspiring me on last Thursday that maybe people are interested in Kubebuilder, so it may be a good start from the Kubebuilder to tell people more about the IQ operator. And then we initialize this controller. Maybe we can call it j.io, like we did last Thursday. And then repo is for demo. And then let's wait for a few minutes. And then after we have this project initiate, we can like create an API here. Let's wait for, oh, it's done. Okay, so next define a resource with create API. So let's create a new API here. Group, let's call it team. Group version v1 kind. Let's call it person. So now I'm create resource, create controller. Yes. So now what we are doing is that we want to define a new kind of resource in a Kubernetes cluster, which is called person, and we can define what the person object looks like. What is the spec? What is the parameter we can have in the spec later in the configuration file. So new API and generate the manifest. Okay, so let's take a look at what Kubebuilder created for us. So here we can see that this is everything that Kubebuilder built for us. So after you initiate your project and create an API, we can see here that these are the. So where's the CRD of it? I think we have like the. Maybe it's not created yet. Okay. So we have so this is the most important function in a controller, which is reconcile, and it's automatically created for us. And what you need to do is just you need to enter the logic of how you want to reconcile this resource. And we can also see here's an example of how you can like create a resource in a Kubernetes cluster, and it's called person because I gave that name before. So let's see what's the next step in the documentation. And then if I like make manifest, let me open a terminal here. Okay, so if we run make manifest, hopefully we can generate the CRD so people can know what's that. Does anyone know where the CRD is? I think it should be here. Oh, yeah, it's here. Okay. So CRD is the custom resource definition. It means that, so this is the custom resource that I just created because before I run the Kubebuilder create API. So this is the one that I created. And this file is the definition of this resource, which is short for CRD. So we need to like deploy this CRD into the cluster to tell the cluster that we have this kind of resource. So later when people do the kube apply some YAML file with this kind defined it in their YAML file, we can know that this is this is the resources we want to create. So so now that
Yeah, so you could really create any object here, right? You can
yeah,
Kubebuilder
right.
allows you just to basically scaffold out that beginning, and then you can add your own logic in. Is the idea?
Yeah, you can add your own logic here in the reconcile function, and this is the definition of the object you want to create. And then we can like define something here in the sample. So we can add some fields here, like for example, what do we want to know about a person? Maybe we don't need like a name, but we can do like age. Yeah, age maybe. And let's see, such 30 maybe, and phone number. Can be something like 1, 2, 3, 4, 5, 6, 7, 9. And then maybe we can know about the address. Something like that. It's just an example, and people can and you can define whatever you want in your own controller. And then so now let's let's see. Oh, right. So before we do that, so this is the spec. So this is what I want. So this is what I want to define in a person, but we need to like define the object here. So what I have here, it should be a, and it's let's stop using calculator here. And then we have phone numbers. And this are string. And actually, you can have some validator here. For example, so if we want to say that the phone number of a person must be like sorry, wait a second. Also, we can see that so we can have so Kubebuilder has this kind of annotation here. It's a special annotation used for Kubebuilder that you can you can say that this string has the maximum length of 10, and if we want to like make sure there's only like 10 characters in the string, we can also set the min length to 10. So this means that this phone number must be like 10. The length of this string must be like 10. If they like only put like 7 or 6, like 7 or 12 like characters there, the validation will fail, and this object won't be created. So so here we add some and this validation can be added to all the like parameters we have here. So it's just an example. And in the state of the parse, we can like add something like this.
Yeah, so Vivek was actually asking a great question. Are these options documented somewhere? Is there like all these Kubebuilder options? Where are they actually documented? Do we know? Is there like
Oh,
official documentation for Kubebuilder?
yeah, it's the one that I was showing. Wait a second. It's here. So this is the official document of Kubebuilder, and I think all the parameter, all the annotation can be found here. Let me search it and. I can't find it now, but I remember I see it somewhere in the documentation.
Let's see here. I just found it. Yes, it's let's see here. I'm sending you in the chat here in the back, the link. So if you look, it's for CRD validation. Is basically the.
Oh, yeah, it's here.
So if on the search, if you just type like there, yeah, it's 562 is the on the left side in the drop down 562. And then here we get the list of all of the different types of validations that we could do.
Mm-hmm. Yeah. Thanks God and Amin for this. And this is where you can find the documentation about that. And then, so what I was trying to do here is that, so after we add this kind of like validations, oh, by the way, they are optional. They don't need to like do that if you don't want to. And then we can run the make install to apply this to apply the CRD into our cluster. Let's wait for a few minutes for that.
Awesome. So this is now going and actually compiling our controller for us, and then it's going to run it locally on our machine, or is it running it within the cluster already?
It's after we do that, there's several steps that we can do to make it run in the cluster. But after that, we can run make it run locally. So.
Okay, awesome. And then it can target the cluster from your own computer.
Awesome. Yeah, right. So if we go back to this quick start documentations, you can see that the CRD is configured because we changed the parameters here. And if we go back to the documentation, we can see that after we create the object, we create the API, and then we change the type and we add some logic in the controller. Oh, we haven't added logic, right? Yeah, I think we can add some logic in the controller to help people actually see something when the controller is running. So let's go back to the controller here. I have some logic that I created previously. I just copy this part of here. So what I'm trying to do here is that I declare a person object, and we can. So here's that if you so here's how the controller works. So the controller will watch the kind of object in a cluster. So for example, here it will watch the person object, and if there's any changes about this project, like of this object, like if there's a new person object being created, or people want to delete or update some object which is already exists in the cluster, the controller will catch that change. So in the request, so each change of the object in the cluster will become a request, and it will be cached. It will be a parameters of the reconcile function, and you can get the which object is being changed and the which namespace this object belongs to. So if we have a function here, it means that it will get the object that has triggered this reconcile function, and we will get it. We will get that object into this person object, and then here I just like print out the phone number of that person. So that is what I'm doing here. And so in order to add some log here, we need something like this. So I need to add a logger here, and then in the main function, there should be we need to define this. I need to define it here. So this will fix the error we have here. And then if I run like declare name logger. Okay. So let's try to make it and make build of this, and then. So what we will do now is that after we have this basic reconcile function and we have that the customer resources defined, we can run the control in the cluster. So if we if we go back to the documentation, there are two ways to run that. So if we just use the make run, it will run locally. But if we like push this to a registry and deploy this cluster, this will be run in a real cluster. And after that, if you want to create an object named person, you can use the sample YAML file in here to create that. And this object will be created in a cluster. But since we only have like 10 minutes here, I kind of think that we should look at the real object, the real controller now. Otherwise, we won't have time for that. So, So this is how we. So this is a real controller. The structure of this is very similar to what we have here, and so if you look at here, this is the customer resources we define in this controller, which is called AKL deployment config. So in this one, we can see that it's exactly same. It's exactly the same idea with this one. So this is all the spec we define in this resources, and then the reconcile logic of it is in the controller's repo, and this is the main function here, the reconcile function. And we can see that so in this function we define the reconcile normal and reconcile delayed, which means that when an object change and it triggered this this controller to reconcile, so which phase of this object it's in. For example, if we create or edit an object, it will trigger the reconcile normal function. But if the object is being deleted, it will trigger the reconcile delete function. So that is what we have here. So the logic here is that when user create a cluster, and they can create this AKL deployment config resources in their cluster, and after that is being created, what this controller will do is that it will. I can't. Reconcile normal. It will reconcile a V and reconcile cluster. So what is in reconcile a V? I can't go into that. No worries. I have it open in the. I have this one open here, so we can like track all the functions here. So reconcile a V. We can see that we create several of these specific projects in order to run AKO in the cluster, and we also have something need to run in reconcile cluster. So this one is the most important one because AKO is converted into an add-on package in Tanzu. So when you if you want to deploy AKO in the cluster, that is the main purpose that I mentioned before. You need to create this AKO add-on in the cluster. So how we create that is the AKO operator will take a look at the AKO deployment config, and then take the parameters and information from that object to create the add-on secret of the AKO package. So we can see that.
So this is basically reconciling the configuration of cluster against an AKO configuration, and then generating a Carvel basically image package secret to run an add-on in the workload cluster. That's how like Avi gets deployed in the workload cluster automatically, right?
Yeah,
from the
right.
management cluster.
Mm-hmm.
Okay.
So for folks who don't really who don't know much about the add-on logic in Tanzu, it's that in the Tanzu Community Edition, we have all the add-on packages that people can install here. And this one, load balancer and ingress, this one is AKO, and you can see the add-on. You can see the add-on templates is here. This is the add-on templates. So the base file is just some YAML file which is fixed, and we have the overlay here to define how we want to override the base file with the parameters that people passed in. So this is how we generate the YAML file for each specific cluster, and then the YTT do this overlay things for us, and then after we have the add-on secret, which contains all the parameters here, the add-on templates and the add-on secret will work together to generate all the YAML files we need to create that. So so if we create the add-on secret here, the add-on manager in the cluster and the key app controller in the cluster will deploy this AKO for us automatically. So basically what AKO operator does here is to create the AKO add-on secret, and the add-on templates is installed in the TCE and Tanzu, and my add-on manager knows where to find these templates. So we only need to take care of the add-on secret in the cluster. And that is how we get this AKO running in the cluster in Tanzu. And I have a mirror board here to show this kind of logic. So first, in Tanzu CLI, if you enable AV, which means that you want to install the AKO in the cluster, the Tanzu CLI will first install AKO and ADC, which is AKO deployment config. And then the AKO operator will create the AKO add-on secret. And the templates is stored in TCE, so the add-on manager and key app controller will combine these two together to deploy AKO in the workload cluster. And if we take a closer look at this AKO deployment config, which is the customer resources we define in the AKO operator, it contains all kinds of parameters here, which is used to deploy AKO. And also, there's a cluster selector here defined in the AKO deployment config, which means that if you create an AKO deployment config in the cluster with the cluster selector, all the workload cluster that can be selected by this AKO deployment config will have the AKO deploy in the cluster. So for example, in my management cluster, create 2 AKO deployment config. Each of them has different labels. And then I create 3 workload cluster. And these 2 have the same label, and this one has a different one. But so that this AKO deployment config is responsible for configure the AKO in this 2 cluster. And this AKO deployment config is only control the AKO in this workload cluster. So after we create this AKO deployment config, the AKO operator in the management cluster will catch this change and create this add-on secret in each workload cluster that it controls. So these 2 can be created together. So the only thing that user need to do is to create this object, and the AKO operator, AKO key app controller, add-on manager take care of the rest part. They will deploy the AKO in the workload cluster. And also, if we change this AKO deployment config, this 2 AKO will pick up the change, but this one will stay the same. But only if you change this one, this AKO operator will pick up the change. So that is why we have this AKO operator. This is one of the benefits of using this AKO deployment config to control the AKO you have here. It means that you don't need to control each cluster one by one. You can control a group of them, which makes the configuration more easily.
It's also, there's something else that's really great about it, because it's in your management cluster, that, when we have an environment, a large Tanzu, deployment, and you have lots of workload clusters that you may be giving to different teams, having it in the management cluster, which is really owned by operations, even if someone were to make a change in the workload cluster, because we're using cap controller, because we're using this operator model with reconciliation, they can break their obby for 5 minutes, but it's going to come back to the way that the operator configured it 5 minutes later. And that's a really strong capability, that we have reconciliation coming from outside of the cluster, so that someone can't just break their own cluster and, change what you wanted it to be as the system operator.
Yeah, exactly. And this AKO deployment config is only in the management cluster. It doesn't exist in a workload cluster. And also AKO operator is only exists in a workload cluster.
Exactly. So it's a really strong way of separating concerns and making sure that we're secure while still giving people clusters that they can manage.
Right. Yeah, so this is how we have that. So this is how we deploy the AKO in the workload cluster. And I think we're about the time to finish. It's already 1 hour. So thanks everyone for watching, and thanks Scott for sharing that Routable feature with us, which is very cool.
Yeah, definitely. And sorry it cut out in the middle, but it was great to be here. And in the last show, I got to show the other integration with NSX for those that didn't see it, with back in the last session with Jay, where we went over the integration of Antrea network policies into NSX. And it's really cool to see these tools really coming together and seeing where it's going with Tanzu. So yeah, this was awesome. Thank you, Xinqi, for having me.
Thanks, Scott, here, and thanks everyone for watching. Appreciate your time.
Bye, everyone.
Bye.